The following video is on graphing exponential and log functions. So we're going to try and figure out the relationship between x and y in these things. Just to make sure that we kind of understand what's going on, we're going to plot some points. So if I plug in 0 for x, 3 to the 0 is 1. If I plug in 1 for x, 3 to the 1 is 3. If I plug in 2 for x, 3 squared is 9. And if I kept going, if I substituted 3 in for x, I'd get 27 for y. And remember, we've kind of already talked about this, but if I sub in -1, y is 1/3. If I sub in -2, y is 1/9. If I subbed in -3, y would be 1/27th, and so on. So essentially what's happening here is we have something where the numbers are getting smaller as we move to the left and bigger as we move to the right. So my function will look something along the lines of this. Now it doesn't do zigzags, but it's kind of hard to graph on a tablet. So it basically looks like a curve that's really close to 0 for a long time, and then it shoots up really, really fast, which makes sense because that's what you would think of for an exponential function. It grows exponentially. We use that word in common language quite a bit. Something's growing exponentially if it grows really fast. Well, it starts off really slow, and then all of a sudden it hits a point and starts growing really fast. So if I'm looking at like what's happening, this function will never hit y equals 0 because I can't take this equation and somehow sub in anything for x and get my y values to be 0. That's just something that doesn't ever happen. So this is an exponential function. Now, we are graphing y equals log base 3 of x over on this side. And I know that if I sub in 3 for x, log base 3 of 3 is 1. That's something that we've worked on numerous times. If I sub in 9 for x, log base 3 of 9 is the same thing as log base 3 of 3 squared. So then I know if I sub in 9, I get 2. If I sub in 1 for x, log base 3 of 1, log base anything of 1 is always 0. If I subbed in 1/3 for x, I would get 1 for y because 1/3 is the same thing as 3 to the -1. And then if I subbed in 1/9, I'm sorry, that's -1. If I subbed in 1/9, I get -2. Notice, just as we've been talking about, these log and exponential functions are inverses of each other. Let's recall from earlier in the year, inverse functions, if we have f inverse of x, we will flip the x and y values. And once we flip the x and y values, we end up getting whatever the inverse function is. So notice that in this table, if I just flipped the x and y values, I would get whatever's going on the log table. So let's try subbing some of these things in and putting them on the graph. So 1, 0, 3, 1, 9, 2, and then they get really close to the axis from there. So this function will be graphed kind of like this. So a log function has a similar situation where the asymptote is now at x equals 0, and the function never actually hits that asymptote. And then basically remember that all the x, y coordinates in y equals 3 to the x, when I convert them over to logs, I'm going to flip what the x's and y's were. So if I'm looking at 0, 1, and 1, 3, for example, they change to 1, 0, and 3, 1. So this point corresponds to this point, and 1, 3 corresponds to 3, 1. So if I graph them on the same axis, it would look something like this, where the exponential's here, the logarithm's here, and the x and y's always match up when you flip them. So um, I'm going to do two more quick examples. These aren't in your notes, but if I sub in 0 for x, I get 1 for y, when y equals 2 to the x, 1, 2, 2, 4, 3, 8. If I sub in -1, I get a half. If I sub in -2, I get a fourth. And so I would have a graph that looks something like this for my exponential function. Notice that I have an asymptote at x equals 0. So that asymptote is something where it's never crossed. In log base 4, these are not inverse functions, notice, because this is a log base 4, not a log base 2. But if I sub in 1 for x, I'm going to get 0. If I sub in 4 for x, I'm going to get 1. If I sub in 16 for x, I'm going to get 2. If I sub in 1/4 for x, I'm going to get -1. And 1/16 for x, I will get -2. So my graph will look something like this, and 16/2 is going to be way over there. So my graph grows really slowly, and I have an asymptote at x equals 0. Now, why am I doing that? I'm doing that because our next problems have 2 to the x and log base 4 in them. So I need to figure out what's actually happening here. Well, it's the exact same thing that I've done all the time. I'm having vertical shifts and stretches and all these other things. So if I look, the +5 means a vertical shift up 5. The x minus 3 means a horizontal shift to the right 3. And this negative in front means that I have a vertical reflection. So let's see if I plug in some points and just kind of see what's actually happening in this graph. Just make some quick understanding so then we can see what's going on in comparison to this y equals 2 to the x graph. So if I sub in, let's say, x equals 3. So if I sub in x equals 3, then I get 3 minus 3 is 0. 2 to the 0 is 1. Now this negative in front mean it's not -2 to the x minus 3. So I'm actually doing this to 2, and then I make it negative. So 2 to the 3 minus 3 is 1. Then I'm going to make that negative, and then +5. So -1 plus 5 is 4. So the point 34 has to be on my graph. If I sub in 4, I get 2 to the 4 minus 3, which is 2. Make that negative. So -2 plus 5 is 3. So 4, 3 is going to be on my graph. If I sub in 5, 2 to the 5 minus 3 is 2 squared, which is 4. Make that negative, so -4 plus 5 is 1. If I sub in 6, I'm going to get 2 cubed. Make that negative, so -8 plus 5 is -3. So my graph appears to be growing fast, going down. And that makes sense because it's a vertical reflection. Now, this vertical shift up 5, let's think about what's happening. I have this asymptote at 0. Well, my graph is going to move up 5. So my asymptote is likely going to be at x equals 5. So I won't have any anything actually hitting the line y equals 5. I'm sorry, y equals 5. So the line, nothing will actually hit the line y equals 5. And that makes sense because there's no way that -2 to the x minus 3 will ever be bigger than 0 or actually even be 0. It's always going to be something that's negative. So my graph should get really close to this asymptote and never touch it. And then notice there's a vertical reflection, and then this horizontal reflection or horizontal shift to the right of 3 means that the normal point 0, 1 got moved to the right 3, and well, basically my horizontal reflection or my horizontal shift moving to the right 3 means that 0, 1 gets moved to the right 3, and then it would normally go up, so it would normally be 6. However, we have this reflection, so instead of the graph going up, it's going down. So you get a couple points. Like, you don't have to graph as many points as I did, but you get a couple points, and then you kind of start figuring out what's happening. So if we look at 3, 4, and 4, 3, if I just graphed these 2 points, I probably would have started to figure out that the vertical reflection is making sense and that it's graphing with like a 2 to the x format. So if I look at this graph in green moved up 5, right 3, and then flipped over the asymptote. Last thing that we're going to graph, log base 4 of x plus 5 minus 3. So I have a vertical shift down 3, a horizontal shift to the left 5 of my log graph. So basically what's going to happen is I'm going to take this log graph, it's going to move down 3 and to the left 5. So I'm just going to plug in some points to make sure that I know what's going on. And it's pretty logical. If I sub in x equals -5, I get a 0 on the inside, so that can't happen. So because that can't happen, I'm going to have a horizontal asymptote or a vertical asymptote at x equals 5. So I can't actually hit x. I can't hit x with anything that's negative either. So now what I'm going to look at is if I sub in -4, I get log base 4 of 1, which is 0. 0 minus 3 is -3. So -4, -3 will be on my graph. If I sub in -3, I get log base 4 of 2. Well, I mean, that's not really going to help me that much. I mean, I can get it, but it's a whole lot easier to sub in things that are going to make the inside multiples of, 4 to a power. So I'm going to sub in -1 next, because -1 plus 5 is 4, and log base 4 of 4 is 1. So 1 minus 3 will get me to -2. So -1, -2 will be on the graph. And then as I graph this function, I'll start to see that it looks a whole lot like this function, shifted to the left 5 and down 3.